Welcome dear students. Today we will discuss the tracing of polar curves. I have already explained you the tracing of Cartesian curves. So in the present lecture I will tell you about the tracing of polar curves. The curves which are given in the form of r and theta are called polar curves. Suppose we have to trace a curve r is equal to f theta. This is polar form. R is equal to f theta. This is general curve in polar form. So in the tracing we use the following steps. In the first step we will check the symmetry. Symmetry about any line means the curve will be same in shape and size on both the sides of lines. First, if we put theta is equal to minus theta in the equation of the curve, and if the equation remains unaltered or unchanged, then we will say that the curve is symmetrical about the initial line. So when the curve will be symmetrical about the initial line, if we put theta replaced by minus theta and equation remains unaltered. Second, the symmetry about the line pi by 2. If we replace theta by pi by 2 minus theta in the equation of the curve, and if the equation remains unaltered, then we say that this curve is symmetrical about the line pi by 2. The curve is said to be the symmetrical about the pole. Third symmetry, if and only if even powers of r occurs in the equation of the curve, then pole is the center and curve will be symmetrical about the pole. And in last, the curve will be symmetrical about the line theta is equal to pi by 4 if the equation remains unchanged when theta is replaced by minus theta and r is replaced by minus r. Means put theta is equal to minus theta and r is equal to minus r in the equation of the curve. If the equation of the curve does not change, it means this curve is symmetrical about the line theta is equal to pi by 4. Values of next step, values of r and theta. If for any real value of theta r is 0, means for any real value of theta if r is 0, then pole lies on the curve, and this value of theta gives the tangents at pole. Means how we will find the tangents at pole? Put r is equal to 0, solve for theta. Those values of theta for which r is 0 are the lines which are tangents at the pole, and we form a simple table for given values of theta. Means theta is equal to 0 for which values of theta we know. For theta is equal to 0, pi by 6, pi by 4, 2 pi by 3, pi, etc. And find the value of r, and we will trace the curve. In some curves, if the curve will have an infinite branch, then means if r has an infinite value for some value of the theta, in such a case we will find the asymptotes, otherwise there is no need of asymptotes. Now we will explain you some tracing of some simple polar curves. First simplest curve is r is equal to a, means here we see that the distance of every point on the curve from the pole is same everywhere, all values of theta. There is no role of theta. That means curve is a circle. Such type of curve can be traced here in the figure. And another simple curve we will explain you. Trace the curve r is equal to a 1 plus cos theta. This curve is known as cardioid, tracing of curve. See the equation of the curve, r is equal to a 1 plus cos theta. If we put theta minus theta in place of theta, the curve comes out r is equal to a 1 plus cos theta, because we know that cos minus theta is equal to cos theta, means curve remains unaltered by replacing theta by minus theta. So in first step we find that this curve is symmetrical about the initial line. In the second step, put r is equal to 0. So a 1 plus cos theta is equal to 0. It means 1 plus cos theta is equal to 0. It means cos theta is equal to minus 1. It means theta is equal to pi. So the value of r will be 0 at the theta is equal to pi. So theta is equal to pi line is the tangent at pole. Clear? Now we form a simple table of theta and r. See here, put theta is equal to 0, we get r is equal to 2a, theta is equal to pi by 4, we get r is equal to under root 2 plus 1 upon under root 2, pi by 2, a 3 pi by 2 minus a by 2, pi 0, etc. and 2 pi, its value is 2a. So maximum value of r is when theta is equal to minimum value will be at pi and maximum value at 2. And trace the curve. When theta is equal to 0, the value of r is 2a, the maximum value. And continuously as theta is increasing, r is decreasing, and up to when we reach pi by 2, it becomes half, means a. And again after pi by 2 it is decreasing, so at theta is equal to pi, r becomes 0. So this curve takes the shape like this, and we know that this curve is symmetrical about the initial line, so the same shape and size will be below the initial line, and the required cardioid is traced here. It takes the form like this. Here now we again trace a curve. R is equal to a cos 3 theta. It is a curve of cosine. So we know that cos minus theta is equal to cos theta. So in this curve, if we replace theta by minus theta, the equation of curve will not be changed. It means this curve will be symmetrical about the initial. In the second step, put r is equal to 0, means a cos 3 theta is equal to 0 means cos 3 theta is equal to 0, and from this we find the values of theta for r is equal to 0 are pi by 6 minus pi by 6, pi by 2 5 pi by 6, 7 pi by 6 and 11 pi by 6. Here I want to explain some another thing. When in a curve r starts from 0 and reaches to 0 means curve starting and ending points are same. So in this range curve forms a loop. So this curve will contain three loops. First loop will be between minus pi by 6 and pi by 6. Second loop will present between pi by 2 and 5 pi by 6. And the third loop will exist between 7 pi by 6 and 11 pi by 6. Clear? Hence, these lines are also tangents at pole. These lines are also tangents at pole. Now we will form a table, theta, giving the values of theta 0, pi by 6, pi by 2, pi by 3, and r's value are a, 0, 0. Using this, first we will, this O is 4. We trace the lines. Theta is equal to minus pi by 6, pi by 6, pi by 2, 5 pi by 6, 7 pi by 6 and 11 pi by 6. These lines are tangent set. And we will start from r is equal to 0 and to reach r is equal to 0 between minus pi by 6 to pi by 6. So this is a first loop. Pi by 2 to 5 pi by 6, this is second loop, and 7 pi by 6 to 11 pi by 6, this is third loop. And we see that in this curve we will get three loops, and the required curve is in this form, r is equal to a cos 3 theta. Now we will tell you the tracing of r is equal to a square cos 2 theta. Lemon state of this curve is also only cosine terms exist in the equation. R is equal to theta, and it is well known that cos minus theta is equal to cos theta. So putting theta is equal to minus cos theta in the curve r square is equal to a square cos 2 theta, it remains unchanged. So you see that this curve is symmetrical about the initial. Also this curve, in this curve, if we put r is equal to minus r, since the power is r square, so there is no effect on this curve. So due to this curve is also symmetrical about O. So r square is equal to a cos 2 theta. Two types of symmetry exist in this curve. First symmetry is this curve is symmetrical about initial line, and second in second step, this curve is symmetrical about the pole. Pole r is equal to 0. We get theta is equal to pi by 4 and 3 pi by 4. So the tangents at the pole of this curve is theta is equal to pi by 4 and theta is equal to 3 pi by 4. Hence the curve passes through the pole and the tangents at pole are given by theta is equal to pi by 4 and theta is equal to 3 pi by 4. For theta is equal to 0, r square is equal to a square cos 0 means r square is equal to a square means r is equal to plus minus a. Plus in the positive direction and minus a in the opposite direction. And form the table theta is equal to 0, 30 degree, 45 degree, 90 degree, 135 degree, 150 degree and 180 degree, and we find the corresponding values of r and we trace this curve. This is of the curve. Again in last we will explain you the tracing of the curve r is equal to a sin 3 theta. There is no symmetry exists in this curve. So this curve, in this curve there is no symmetry. Second step, put r is equal to 0. So sin 3 theta is equal to 0 means 3 theta is equal to 0, pi, 2 pi, 3 pi, 4 pi and 5 pi. It means divide by 3, theta is equal to 0, pi by 3, 2 pi by 3, pi, 4 pi by 3 and 5 pi by 3. Clearly, these lines are tangents at pole. When it tangents at pole are theta is equal to 0, theta is equal to pi by 3, theta is equal to 2 pi by 3, theta is equal to 5, theta is equal to 4 pi by 3 and theta is equal to 5 pi by 3. Also see that the value at theta is equal to 0 is 0, r is 0 and at pi by 3 r is also 0. So in these consecutive intervals of theta, this curve will form a closed loop. First loop will be between theta is equal to 0 and theta is equal to pi by 3. Second loop will be 2 pi by 3 and pi. And third loop will be 4 pi by 3 and 5 pi by 3. We find the maximum value of r. We put dr d theta is equal to 0. So cos 3 theta is equal to 0. So 3 theta is equal to pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2 and 9 pi by 2. And theta is equal to pi by 6, pi by 2, 5 pi by 6, 7 pi by 6, 3 pi by 2 and this. And we see that d2 r d theta 2 is negative for pi by 6, 5 pi by 6 and 3 pi by 2. So at these values, at theta is equal to pi by 6, theta is equal to 5 pi by 6 and theta is equal to 3 pi by 2, r has maximum value and its value comes out to be a. So there is a first loop between theta is equal to 0 and pi by 3 and its maximum value is a at theta is equal to pi by 6. Second loop is between theta is equal to 2 pi by 3 and theta is equal to pi and its maximum value occurs at 5 pi by 6. And third loop is between 4 pi by 3 and 5 pi by 3 and maximum value occurs at 3 pi by 2. And shape of this curve is shown as in the figure. So we have explained you some simple curves which are given in polar form, and prepare, trace the curve at the home, do exercise and ask if any doubt. Thank you.